Today I'm going to talk about how selectness is expanding the market for biochar with analysis, application testing, and upgrading. But wait a minute, who I am? Well, for those of you that don't know me, I might not have a decade of experience working with biochar. In fact, I just came to know about that biochar existed like 3 years ago, but the topic just hit me like a thunderbolt. And now I'm so invested that sometimes you will even find me losing my sleep working on something on biochar. So it's something that it has been really, really special, and I'm very happy to be here. So I wish to all of you that you can enjoy the presentation. And besides who I am, I think it's very important to mention where I work. I work in selectness. We're a biomass chemistry lab. We specialize in analysis, but we also have experience on different biomass conversion methods. And before selectness, actually, there was a prehistory. Selectness was born about 10 years ago, inspired by the lack of available literature about lignocellulosic composition. And as any other PhD, that gave an opportunity for research. So Selectness CEO, Dan Hayes, focused his PhD on developing rapid analysis methods for lignocellulosic composition. And I can tell how important it is to have rapid analysis method because the chemical weights, they are just so time consuming and resources consuming. During his PhD, the research group secured funding for 3.7 million for advanced biofuels research. The project name back then was DivaNet. Some of you might know about this. And essentially, DivaNet developed a database for the composition of Irish feedstock. So from this, a business plan for setting an analytical biomass company started. Selectness was registered in July of 2013, launched in August of 2014, focused on second generation feedstock. On 2016, secured his first Horizon 2020 research project. On 2018, there was a further expansion of equipment for thermal and anaerobic digestion, both analysis very relevant in the space of biomass, but also very relevant in the space of biochar. Biochar when can be used as a solid fuel or when it can be used as an additive for anaerobic digestion. This is important. In 2020, there was another expansion in funded European projects. At the moment, we are active in 10. 2021, there was 14th expansion on analytical services. Back then is when we started to officially offer analysis just focused on biochar. In 2022, we had the addition of a new location focused on scaling up bioprocess activities. And in 2023, we have a further expansion on analytical services for plant growth promotion, which in fact, just during May, we have been working with around 672 plants. Very, very happy days, also very, very consuming working with the plants. It's intense labor, but it's very nice. And how all of this is relevant? Well, we are here to talk about biochar, but also biochar before being a carbon-rich product, it's a feedstock. And that feedstock and its composition can have an important impact on the product, the potential applications, and even how easy or how difficult it is to add value to that pristine biochar. So I would like to start talking about the lignocellulosic composition. Lignocellulosic feedstocks have structural and non-structural components. On the side of the structural ones, we have cellulose, hemicellulose, and lignin. And on the side of the non-structural ones, we have extractives, also known as soluble compounds, and we have ash. Each of these components degrade at a different temperature when going a thermal transformation process. For example, cellulose start to degrade a bit under 350 and reach till up to 350, hemicellulose around 260, lignin around 500 degrees, extractives under 260, and then ash about 550. And this is important because if we have a feedstock that is very rich in cellulose, because of the natural morphology of cellulose, we can end up with a biochar that it has a very nice porous structure. On the other hand, if we have a feedstock that is rich in hemicellulose, because of how low the degradation temperature starts, we might end up with a product with very little yield. On the other side, lignin, which is a polyaromatic compound, when going through thermal degradation, some recalcitrant carbon bonding can be formed. And this is what ultimately will allow biochar to remain in the long term as a stable carbon. Then on the hand of extractives and ash, there can be very positive things about those two components, but there are also some maintenance associated costs in case of the extractives turn into tars or condensable compounds that are just messing up with the equipment. Also, ash can melt and reduce the heat transfer of the production system. And we have the solid fraction of making biochar, but we also have liquids. And these liquids can be very complex mixtures, relevant when we're talking about wood vinegar. And if this wood vinegar is rich in sugars, can be used for producing liquid fuels. On the other hand, if it's rich in sugar degradation products, can be used to produce biopesticides. Or if there are some interesting extractives or plant hormones, they can be used as plant growth promoters. So it's also very important to pay attention to the composition of the liquid fraction. And how this composition affects the thermal properties? Well, depending on how much volatile matter we have is how much fixed carbon we will end up at the end of our process. And when it comes to carbon, hydrogen, nitrogen, and sulfur analysis, we can obtain the hydrogen to carbon ratio, which is a very important, if not the most important, parameter at the time of defining how stable is that carbon and for how long it will remain stable in the soil. Then obviously this composition will have an impact on the heating value if biochar is used as a fuel. And also if that biochar has a high chlorine content, this can create corrosion on the system. Or if the ash produced from biochar has a low ash melting temperature, then that will just completely reduce the heat transfer capacity of our system. And talking about composition, I really want to mention how important it is to consider that there could be the possibility of having some very nice compounds in our original feedstock, and that we are completely destroyed by just focusing exclusively on biochar. And let's take seaweed as an example. And I would like to do this analogy first. If we are just walking on the beach and we find a shell, we might think, oh, okay, it's nothing. But if we would know that inside that shell there is a pearl, we would be much more interested. It's more or less the same with seaweed. I mean, seaweed is actually a very interesting feedstock. It has very interesting carbohydrates, amino acids, fatty acid, pigments, and some high value biochemicals that if valorized with a cascading approach, we can take value of different things. So that's why it's very important when thinking on producing biochar to do a feedstock profiling, because we might be finding some hidden gold in the biomass that if we just go directly to pyrolysis, we might be missing. Profiling helps us to identify high value constituents. And just to come as an example, we had a project called Unravel, when we identify, extract, and purify betulin. Betulin is a very rich constituent that can be found in biomass. And yeah, you extract that, and then you continue valorizing in whatever form you want your feedstock, which ultimately, once you extract the betulin or any other valuable component, you can turn that byproduct, or some people could call it residue, into biochar. And then how the composition can have an impact on some non-conventional applications. And this I'm talking when we are not going to use biochar just as a soil amendment. But for example, in anaerobic digestion, if we were going to add that biochar as an additive, if originally we have a high cellulose content, we might end up with a very nice porosity, and that porosity will be very beneficial for absorbing heavy metal and other contaminants present in an anaerobic digestion. Same with the porosity, with the morphology, or with the different chemical structure of the biochar. It could be used as a reaction catalyst in other bioeconomy activities like enzymatic hydrolysis and fermentation. Composition can be also very relevant at the time of thinking on producing functional bio-based materials adding biochar, because if the biochar can actually cross-link with the material that we are thinking to produce, then we can end up adding value to that material rather than exclusively just charging or reducing the carbon footprint of that material. So if the composition is so important, how to choose? I mean, it can be overwhelming to decide what is the best feedstock. Well, the reality is that this is something very difficult if there is not such a thing as the right feedstock. We can have clean forests, feedstocks, agri-residues, organic textiles, municipal waste, food waste, sewage sludge, but every single feedstock has its pros and cons. For example, with clean forests, you will have a very homogeneous composition, you will be familiar with the composition, and you will know how to approach it, but it can be expensive. On the other hand, agricultural residues might be more affordable when it comes to the price, but are not in your region. I mean, if you want to produce biochar with avocado stones, but you are living in a country that there is not avocado plantation at all, then it's not a good feedstock. Then C1 can be very, very abundant, but it's also a wet feedstock. And you have to consider how energy intensive could be to take out the moisture out of it. Then municipal waste, there must be some incentive for some governmental programs that even incentivize the disposal and the management of this waste. But if we produce biochar from that kind of waste, we might not be able to use this biochar as a soil supplement or to promote the plant growing. So I would like to mention some analyses that are particularly interesting to me, because I think that when it comes to analysis, and although this podcast is this webinar is international, we are based in Europe, and some people might think about analysis as, okay, let's just comply with the European biochar certificate. But it's also about understanding what do I have on my feedstock, how my biochar looks after production, how the different characteristics of this biochar can be used for the best value. Because we might be obsessed of thinking, okay, I want to use this biochar just for plant promotion. But maybe actually your biochar is great as a construction material. And just because that, you are having an opportunity cost. So I would like to take 3 examples of analysis that I really like. One of them is porosity. And to me, it was surprising that a few months ago, we carried some water extraction on some biochar just as an internal research, nothing special, just completely out of my own curiosity. And I realized that after doing water extraction or water leaching on that biochar, the porosity increased by 50%. And I mean, biochar quenching is a common practice, but some people might pay more or less attention to it. So we have to consider how water interacting with the char can actually impact on something as important as the porosity. Then another analysis that is really very interesting is thermogravimetric analysis. We might all think about product yield is something very important, but we don't need to run a full batch, or we don't even need to run a pilot scale batch to know what's going to be our product yield. TGA is actually very precise, it's economical, and can give us a very, very good idea if our feedstock will give us a good product yield at a given temperature. Then another analysis that I really like is the polyaromatic hydrocarbons and heavy metals. And I would like to do the analogy that it can be easy to confuse a slice of pizza with a slice of watermelon, or an orange with a donut. And this can happen with biochar. You can see a biochar that is very nice, that just looks amazing, but once you analyze it, you find out that it's a toxic compound, and that can have PAHs there, or heavy metals that ultimately can impact plants or even consumer materials. Another analytical test that to me are very important, relevant, worth noticing is when it comes to plant growing, major and minor elements will give us obviously the nutritional value of that biochar. Then water holding capacity, we all heard that biochar can help to reduce the water consumption, but is actually that char good for holding water? Then cation exchange capacity is another one very important. How good is your biochar enabling the access to those nutrients that will be absorbed by the plants? And then carbon credits is another very hot topic that we all pay attention. So in order to really think how stable is your char, we will need to do a carbon analysis and to consider how much inorganic any organic carbon is in the chart. Then plant growth trials is also a beautiful part of working with biochar. And if you do plant health analysis, not only focusing on the appearance, the height, the root, if you study the chemistry of the plant, you can realize that adding some type of biochar can be beneficial for some pigments development that help plants to grow faster, can have a better nutrient uptake, and the whole chemistry of the plant can actually change adding the right biochar. Also, the soil biology is something that completely changed. Biochar can be beneficial for the microbial community present in the soil and how the bacterial and fungal community change. Is there any soil enzymes that are acting there, degrading that carbon that we're supposed to maintain stable for the long term? Or are those enzymes actually helping to solubilize phosphorus that is good for the plant? And I have been talking about composition, analysis, and how this can have an impact on applications. But I also would like to talk about how we can add value to that initial biochar, thinking on really just making them the most out of a conventional product. Because the price according to the end use can really change. It's not the same having just bulk biochar or thinking on biochar as a construction additive or for urban applications on urban trees or for as a transesterification catalyst, for animal feeds, or even for some electronics applications like the case of graphene oxide or carbon nanotubes. Because the truth is that biochar produced from ordinary pyrolysis procedures without additional treatment usually possess relatively low value. And we might think that we have a very nice product, like if we would think of a dog, a very beautiful dog, but maybe we are just dreaming and actually we just have a balloon dog. So we have to stay attached to reality and think if we have the facilities and the possibilities of doing additional treatment for current activation, whether it's physical or chemical, co-composting that char, doing some water leaching, some heat treatment or aeration, or even thinking on aging. And I mean, physical activation is just something as gaseous activation, referring to the activation process involving oxidizing agents such as carbon dioxide, steam, and air. And these oxidizing agents will react with the tar trapped in the pores, opening those block pores. It's very similar with chemical activation. That chemical will react with those trapped substances in the pores of the char, and that reaction will release some gas, and that gas will be very beneficial for the development of the pore structure, together with some functionalization that can start to create this chemical structure variable for catalysts or materials, electronics applications. And actually just something very recently caught my attention, and it's coming from the inspiration of the kitchen. There is some studies working on potassium bicarbonate stimulated from bread leavening, where the potassium bicarbonate, the composition occurs at low temperatures, around 200 degrees, and along with the release of that gas, this assists to the development of the porosity, and just very similar to what happened in the kitchen when we are making bread. Another interesting upgrading procedure that I have been mentioning is just water leaching. There are some compounds that are soluble, like minerals, potassium, sodium, but also some liquid compounds that are soluble coming from the wood vinegar, as acetic acid and phenol, that can positively impact the cation exchange capacity or the presence of some contaminants of the char. And I mean, even those leachants can potentially have bioactive compounds that can act as biostimulants and can promote plant growth. So you start with a single product, and after doing water leaching, you might end up with two products instead of one. Heat treatment and aeration is another very interesting upgrading process, because fresh produced biochars can contain sorbate occluded gas phase coincidents, such as the plant hormone ethylene. Or another great example is naphthalene, which is generally the most abundant polyaromatic hydrocarbon of toxicity concern. And naphthalene is highly volatile, but has low water solubility. So if it goes through quenching, you are actually not doing nothing to those volatile compounds. And it's just for me hard to believe sometimes how little attention is paid to aging, because we cannot think that just as soon as we produce the biochar and we add it into the soil, that biochar will remain the same for years and years and years, especially if we are thinking of centuries or even 1,000 years. So to see how that aged biochar will behave in terms of the composition or the application, or how this biochar will impact plant growing, I consider it's also very important to keep in mind. So everything that I have been saying before, it can be found in the selectness Biochar Hub. There you can find lots of information about feedstocks, biochar analysis, surface area, thermogravimetric analysis, carbon sequestration, relevant topics. I really hope that all of you enjoy the presentation. Thank you. I'm Edgar Ramirez Huerta. You can find me on LinkedIn or email me at edgar@selectness.com. Thank you. Thank you, everyone.
Thank you, Edgar, for your nice presentation. And I can say, so we also work with selectness sometimes. So good guys. So you got some questions. I mean, you got a discussion going on in the chat, but I want to go to the specific questions first. So Marshall was asking, how does your analysis of biochar align with the IBI characterization or EU standards?
We cover all the IBI except PCBs and dioxins, but we are working on it at the moment. And we cover all the analysis on the EBC.
Okay, and I guess, can you say your EBC package price?
Probably wouldn't be the best idea on the webinar, but not because of the price. But we work with universities, we work with the startups, we work with big consortiums, and we price different according to the volume and to how regular are the clients.
Yeah.
But if someone comes from this webinar to ask for first information, mention it, and I will try to negotiate with my boss for maybe a promo.
So the next question was, please compare, I just read it out, please compare and contrast absorption as an activated carbon uptake and specific surface area as measured by BAT methods. Or more general, how do you measure porosity in selectness?
Well, it really depends of the customer needs. We are not have anything written on stone. It really depends of customer needs. If the customer tells us we would like to do it with argon, with liquid argon, with CO2, as long as there is potential for continuation, we have the infrastructure for these things. Nonetheless, the most popular package is still according to the EBC guidelines, which is with liquid nitrogen, with nitrogen as a gas, and we follow the degassing conditions that are mentioned there.
The next question was from Charles Heckberg. Can you do electron storage capacity, the geobiological battery, not the cation exchange capacity?
It's something that I don't work directly. So I would prefer if we could address this through mail, because at the moment I don't have it clear.
Yeah. And Tatiana was asking, do you know which kind of project did you have with Embrapa?
With who?
Embrapa. I also don't know what project, if that's an organization or I'm not sure.
No, just recently we crossed the line of 1,000 customers, was 1,000 users. So I'm not familiar with all the projects that we are doing. Yeah. I'm sorry.
And then maybe there was a general discussion. So do you see, just from experience, maybe you have some insights, do you see a higher value in the construction material side of application or in the agricultural applications?
Oof, I actually like both very much. I am myself genuinely oriented to agriculture, but just because I have passion for the topic, I grow up on a farm, and that's why probably biochar just hits me really like a thunderbolt, and I'm so excited about the topic. However, actually my best friend, he's an architect, and I have regular conversation about construction when I'm having a pint with him. And I just see so much potential also in the construction space. So I think both are very nice areas of application.
Okay, great. So we are perfectly on time. Thank you again, Edgar. And if you have any questions to Edgar or to selectness, so you see the email address here, and you can also find the presentation afterwards online.